Astronomers have discovered thousands of exoplanets, and a few of them, like TRAPPIST-1e, look like ideal candidates for life. It is a rocky, Earth-sized world orbiting right inside its star's habitable zone. But at 41 light-years away, a pristine planet like this remains out of our reach. Imagine we could bypass the interstellar commute entirely. What if we simply teleported an Earth-sized exoplanet directly into our own solar system? On a map, there are tens of millions of miles of empty space between our planets where we could park a second home. Looking at this model of the solar system reveals the problem with that plan. These voids are actually filled by a state of constant gravitational tension. Every object in our system exerts a permanent, invisible, and opposing physical force on everything else. Adding a massive body to this grid instantly alters the tension. The new mass yanks on every single line of gravitational force in the network. The solar system has spent billions of years settling into a precise balancing act. Any new addition shifts that balance, threatening to unravel the entire structure. We can test this by moving two rocky worlds, TRAPPIST-1e and a massive super-Earth called Kepler-442b, into the gap near Mercury's orbit. This immediately triggers an atmospheric disaster. Placing Kepler-442b so close to the Sun boils its oceans into vapor. Because this super-Earth has such powerful surface gravity, it traps that heat, creating a runaway greenhouse effect that turns the entire world into a hellish version of Venus. The surface temperature is only the local problem. Kepler-442b has 2.3 times the mass of Earth. This introduces a heavy new gravitational drag that pulls on every planet in the inner solar system. This orbital map shows the rogue mass of Kepler-442b distorting the paths of Venus, Earth, and Mars. Over millions of years, they warp into erratic ovals. Eventually, those paths overlap. The planets will be thrown out or enter a direct collision course. Placing a planet close to the Sun dooms the exoplanet to a climate trap, while simultaneously setting a million-year ticking clock on an inter-system orbital mashup. To avoid the Sun's heat, we can try moving the experiment further out. We'll take a massive super-Earth named Ogle and place it into the asteroid belt between Mars and Jupiter. This creates a scale mismatch. Ogle is 5.5 times heavier than Earth, and we have just parked it inside a field of millions of loosely bound small space rocks. Ogle's extreme density acts like a cosmic wrecking ball, violently yanking nearby asteroids out of their stable flow. Millions of these rocks are now spiraling inward, creating a perpetual meteor shower aimed directly at the orbits of Earth and Mars. Utilizing the empty space in the middle of our solar system turns a passive debris field into a catastrophic shotgun blast fired at the inner planets. Finally, we'll look at the deep outer system. This is J1407b, a gas giant 20 times the mass of Saturn with rings 200 times wider. We'll place it right between Saturn and Uranus. The local damage is immediate. J1407b's sheer size acts as a celestial broom, destabilizing the orbits of Saturn and Uranus's moons and sweeping the surrounding region clean. The greater danger involves our orbital anchors. Large gas giants like Jupiter are the heavyweights that dictate the gravitational balance of the entire solar system, keeping the smaller rocky planets in their safe zones. J1407b is massive enough to nudge Jupiter off its axis. As this map shows, a tiny shift in Jupiter's position violently disrupts every planet closer to the Sun. Earth's climate spirals out of control, while Mercury is flung entirely into the Sun. In a deeply interconnected system, disrupting the heaviest anchor guarantees the collapse of the entire structure. Distance offers no protection. The gaps between worlds are actually a rigid network of gravitational poles. There is no such thing as empty space in our solar system. This math is unyielding. While planetary collisions might take hundreds of millions of years to occur, the destruction is mathematically locked in the moment a new mass arrives. Our solar system is a closed ecosystem. It spent 4.5 billion years eliminating unstable orbits to achieve the precise clockwork we see today. Bringing an exoplanet into our neighborhood wouldn't provide us with a second home. It would actively destroy our first one. Earth is our only home because of its oxygen, its liquid water, and its irreplaceable position in the cosmic web.